September 1940, while Cambridge-trained aerodynamics experts were redesigning entire wing structures trying to solve the speed problem that was losing RAF Fighter Command the Battle of Britain, a 23-year-old ground crew mechanic with a 6th-grade education grabbed a roll of fabric tape and accidentally increased Hurricane fighter speed by 34 miles per hour in 3 hours. How did a modification so simple that it cost less than 2 shillings completely escape every aeronautical engineer, every Air Ministry scientist, and every aircraft designer in the Royal Air Force? The rain hadn't stopped for 2 days at RAF Northolt. It had turned the airfield into a gray expanse of mud and anxiety. James "Jimmy" Mackenzie knelt beside Hurricane P3878, watching performance reports pile up that told the same grim story. Each sortie report represented another pilot who couldn't catch a Messerschmitt 109, another squadron that couldn't intercept bombers before they dropped their loads on London, another day Britain was losing the air war because their fighters were too slow. This is the true story of how a 23-year-old aircraft fitter stumbled onto an aerodynamic modification that would transform the Hurricane from an obsolete fighter into a Bf 109 killer and change aircraft maintenance forever. But on that rainy September morning at Northolt, nobody was listening to Jimmy Mackenzie. Nobody thought a mechanic from the Glasgow slums could solve a problem that had stumped the best minds at the Royal Aircraft Establishment. The RAF was losing the speed war catastrophically. Hurricane Mark 1s topped out at 318 miles per hour in level flight. Messerschmitt Bf 109Es could hit 354 miles per hour. That 36 miles per hour difference meant Hurricanes couldn't catch German fighters in a dive, couldn't escape when outnumbered, couldn't intercept bombers before they dropped their loads on London. That meant for every 10 interceptions attempted, 6 failed because the Hurricanes simply couldn't get there in time. The other 4 succeeded only if the Germans made mistakes or the RAF got lucky with positioning. 1 in every 3 sorties failed to engage the enemy at all. The Hurricanes climbed desperately toward bomber formations, only to watch Bf 109 escorts dive on them from above, too fast to evade, too fast to counter. Their precious minutes of fuel burned while German bombers reached their targets unopposed. The RAF was bleeding fighters, and the bleeding was getting worse. Without speed superiority, the entire defense of Britain teetered on collapse. Hurricane squadrons sat at readiness watching radar plots, knowing they couldn't reach the bombers in time. Spitfires were too few to cover every sector. Ground crews watched pilots climb into obsolete aircraft day after day, watched them return shot up or not return at all, because the Hurricane couldn't dodge bullets it couldn't see coming. Hermann Goering understood this. He watched RAF fighters struggle to intercept his bomber streams, watched them get bounced by Bf 109s they couldn't outrun. Every failed interception gave him another hour, another raid, another step toward breaking British resistance. Jimmy Mackenzie was nobody special. He'd grown up in the Gorbals outside Glasgow during the worst years of the Depression. His father had taught him to fix motorcycles using scrap metal and prayers because new parts cost money they didn't have. School ended when Jimmy turned 12. His father needed him full-time at the repair shop they ran out of a shed behind their tenement. No formal education past basic arithmetic and reading. But Jimmy understood airflow the way some people understood music or mathematics. He could watch smoke from his father's cigarette and know exactly how it would move. He could look at a motorcycle fairing and see turbulence that others couldn't. When war came, Jimmy enlisted on his 18th birthday in 1935. The RAF tested him, found he could fix anything mechanical, and sent him to Northolt as an AC2, aircraft hand, not a rigger, not a fitter, just the lowest rank who cleaned spark plugs and fueled aircraft. That's what he was doing at Northolt in September 1940, servicing Hurricanes, watching performance reports, and wondering why nobody seemed to care that their fighters were being murdered by aircraft that were simply faster. The RAF cared, of course, they cared desperately. They had assigned their best aerodynamics experts to solve the speed crisis. Men from Cambridge and the Royal Aircraft Establishment, experts in fluid dynamics and structural engineering, worked day and night on the problem. Their first solution was to modify the wing's internal structure, reinforce the main spar to allow steeper dives, reduce internal bracing weight to improve power-to-weight ratio, adjust control surface balance to reduce drag. They tested dozens of configurations at RAE Farnborough. The modifications helped a little. Top speed increased by maybe 8 miles per hour on a good day with a fresh engine. But the changes were expensive, time-consuming, and required specialized riggers to install. Each modification cost over 340 pounds, required 3 qualified fitters, and took 47 hours per aircraft. And 8 miles per hour wasn't enough, not nearly enough. Other experts recommended high-octane fuel additives mixed into standard aviation petrol to increase engine performance and reduce detonation. The additives worked in laboratory tests, but shipping millions of gallons of special fuel mixture to forward airfields was impossible. The supply chain couldn't handle it. The tanker trucks that were supposed to carry the additives couldn't reach their destinations because German bombers kept hitting supply depots. It was a problem that ate its own solution. High Command considered withdrawing Hurricanes from frontline service entirely. Maybe the design couldn't be fixed. Maybe RAF fighters would have to accept being slower than German aircraft. Maybe Britain would lose simply because the RAF couldn't figure out how to make their fighters fast enough without redesigning them completely. Jimmy watched all this happen. He watched engineers work on wing spars. He watched officers argue about fuel chemistry. He watched Hurricanes leave Northolt with fresh modifications and return with the same speed problems. And Jimmy noticed something nobody else seemed to see. The Hurricane's fabric-covered wings were rippling in flight, creating massive drag that was bleeding speed. Those fabric panels on the outer wings, hundreds of square feet of doped Irish linen, stretched tight over aluminum frames when new. But after a few dozen sorties, after rain and sun and the stress of combat maneuvering, the fabric developed tiny ripples, not tears, just subtle waves in the surface. The dope coating tightened some areas and loosened others. Standard Hurricanes had these ripples across 60% of their wing surface. Nobody paid attention because they weren't structural problems. The wings held together fine. But those ripples created turbulent boundary layer separation across the entire wing, significantly increasing drag and killing top speed. By the time Hurricanes reached operational squadrons, the wings looked smooth to the eye but felt rough under a hand run along the fabric. And that roughness, those millimeter-high ripples, was costing them 30+ miles per hour. Jimmy mentioned this to his flight sergeant, a regular RAF man who'd been maintaining aircraft since 1928. The sergeant barely looked up from his inspection log. "Kid, we got RAE Farnborough engineers on this problem. You think they haven't considered fabric tension? The problem isn't in the power plant and airframe weight. That's where the experts are focused. Get back to work." But Jimmy couldn't let it go. He'd grown up in a shop where aerodynamics meant the difference between a motorcycle that could hit 70 miles per hour and one that topped out at 50. His father had taught him to tape over gaps in fairings, smooth out rough spots, eliminate any surface irregularity that created drag. Never leave rough edges where air could catch. Never accept ripples where flow needed to be smooth. The fastest motorcycles were the ones with perfect surface finish, not necessarily the ones with the biggest engines. Jimmy had spent his childhood making power stretch, because more power meant parts they couldn't afford. And now he was watching the RAF waste speed like it didn't matter, focusing on complicated structural modifications while ignoring the simple fact that half their wing surface was creating drag that shouldn't exist. The problem wasn't the wing structure, Jimmy thought. The problem was the fabric itself. But he was 23 years old with a 6th grade education. And who was going to listen to him? Jimmy couldn't sleep. Every night he lay in his bunk thinking about those rippled wings, watching speed bleed away while engineers fiddled with wing spars. He kept remembering something from his childhood, a memory that wouldn't leave him alone. His father used to smooth motorcycle fairings using strips of rubberized canvas, gluing them over gaps and rough spots to create a continuous surface. Not just any tape, but thin fabric-backed adhesive strips that he'd smooth carefully over every seam, every rivet, every irregularity. The bikes ran faster that way, didn't vibrate as much, got better fuel economy. His father had learned that trick during the Great War, when mechanics used fabric dope and canvas patches to temporarily smooth damaged aircraft surfaces. What if the RAF was solving the wrong problem? What if those brilliant engineers were looking in the wrong place entirely? Jimmy started thinking about the fabric wings themselves. The standard Hurricane wings had ripples because fabric tension was impossible to maintain uniformly across large panels. Wind loads during flight created stress. Temperature changes created expansion and contraction. The dope coating cracked microscopically, allowing the fabric to move slightly against the underlying structure. Made sense in theory to use flexible fabric. It was lighter than metal and easier to repair. But those big fabric panels also created drag that rigid surfaces wouldn't. Combat stress created ripples. Ripples created turbulence, and nobody was doing anything about it because it wasn't a structural problem. Jimmy's idea was radical in its simplicity. Don't modify the wing structure, don't redesign the fabric attachment system, just smooth over the ripples. Apply fabric tape along the chordwise direction of the wing, spanning from leading edge to trailing edge, covering the rippled areas. Use thin, dope-impregnated fabric tape that would conform to the wing surface, fill the ripples, and create a smooth aerodynamic surface. The tape would add negligible weight, but would smooth the boundary layer, preventing turbulent separation. And do something about the gap between wing root and fuselage, where air was spilling through and creating vortex drag. Tape over those gaps too. Create a continuous surface. He started experimenting in secret. After his regular shifts ended, Jimmy would stay late in the maintenance hangar, working by lamplight when everyone else had gone to sleep. He pulled Hurricane L1592 from the rotation, a battle-damaged aircraft waiting for major repairs, condemned for combat use but still airworthy for testing. Using standard aircraft fabric tape from the supply stores and extra-strength dope from the paint shop, he applied long strips along the wing's chordwise direction, smoothing over every ripple, every uneven area, every surface irregularity. Each strip was 2 inches wide, applied with careful overlap, then doped smooth to blend into the existing fabric surface. Then he needed to seal the wing root gaps, the spaces where the wing joined the fuselage. These gaps were intentional, designed to allow wing movement during flight, but they were also massive drag sources. Air spilled through these openings, creating vortexes that disrupted flow over the entire rear fuselage. He fashioned a simple fairing using fabric tape layered in multiple strips, building up a smooth transition from wing to fuselage. The fairing flexible enough to accommodate wing movement, but smooth enough to prevent air spillage. 3 weeks passed. Jimmy worked every night, taping L1592's wings one section at a time using materials he scavenged from the hangar. Nobody paid attention to what the kid was doing in the corner after hours. He taped over 40 square feet of wing surface total. Each section got the tape treatment, applied smoothly, doped carefully to eliminate any ridge or edge that might create its own drag. He tested the surface by feel, running his hands over every inch, feeling for any irregularity. Too rough and the tape was adding drag instead of removing it. Too smooth to feel meant it was working. He couldn't flight test the aircraft himself. He wasn't a pilot, but he could measure surface smoothness and he could document the modification. He filled a notebook with diagrams showing exactly where he had applied tape, how many layers, what doping technique worked best. Now came the hard part. Jimmy needed to convince someone to actually flight test his modification. He approached his flight sergeant again, this time bringing his notebook with detailed documentation of every tape application, every surface measurement, every technique used. The sergeant looked at the notes, looked at the taped Hurricane, shook his head.
This isn't your job, Mackenzie. You're an aircraft hand, not an aerodynamics engineer. You want to change how the whole RAF maintains Hurricanes. That's above your pay grade, way above. But there was one person who might listen. Squadron leader Jeffrey Harcourt ran 303 Squadron out of Northolt. Jimmy had worked on Harcourt's personal Hurricanes several times, and the officer had always been decent to him, never talked down the way some of the others did. Harcourt was also desperate. His squadron kept losing engagement opportunities because Hurricanes couldn't catch BF-109s, and pilots were dying because they couldn't escape when bounced. Desperate men take chances they wouldn't normally take. Jimmy found Harcourt in the dispersal hut on September 18th. He brought his notebook and asked for one test flight on L1592, just one flight measured against a standard Hurricane, to see if the tape made any difference. Harcourt listened, which was more than anyone else had done. He looked at the taped wings, ran his hand over the smooth surface, compared it to a rippled fabric on a nearby Hurricane. Then he asked Jimmy a simple question. "How much did this cost you to make?" Jimmy did the math. Standard fabric tape from stores, standard dope from the paint shop, maybe 40 man-hours of labor. Maybe 2 shillings in materials? Maybe less if we're not counting my time. Harcourt whistled low. The RAE modifications cost 340 pounds per aircraft. Tell you what, Mackenzie, I'll test your fancy tape job tomorrow morning. We'll see if it makes any difference. That was all Jimmy needed. He stayed up all night checking every inch of tape on L1592, making sure every edge was smooth, every seal was perfect. The test flight launched at 0730 hours on September 19th. Standard procedure was to measure top speed and level flight at 15,000 feet. Harcourt took L1592 up with a stopwatch and an airspeed indicator that had been calibrated the day before. 30 minutes later, he landed. Standard Hurricane top speed at 15,000 feet, 318 miles per hour. L1592 with Jimmy's tape modification, 352 miles per hour. 34 miles per hour faster. Not 8 miles per hour like the expensive structural modifications, not 12 miles per hour like the fuel additives, 34 miles per hour faster using 2 shillings worth of fabric tape and 1 mechanic's obsession. And the Hurricane handled better. Lighter control pressures, better roll rate. The smooth wing surface reduced drag so much that the entire aircraft felt more responsive. Harcourt found Jimmy in the hangar, grabbed his shoulders. It worked. Holy Christ, Mackenzie, it actually worked. You just made my Hurricane as fast as a Spitfire Mark I. Do you understand what this means? Harcourt took the results straight to Group Captain Stanley Vincent, the station commander responsible for all Northolt operations. Vincent was a career officer who'd built his reputation on efficient squadron management. He was also watching his carefully planned defenses fall apart because Hurricanes couldn't catch German fighters. When Harcourt showed him Jimmy's numbers, Vincent made a decision that could have ended his career if it went wrong. He ordered a full field test, 12 Hurricanes, 6 with standard fabric, 6 with Jimmy's modification. Measured speed runs at multiple altitudes. Every aircraft's performance tracked precisely. It took Jimmy and a hastily assembled team of 4 aircraft hands 3 days to modify 6 Hurricanes. They worked around the clock applying tape, doping surfaces, testing smoothness. The hangar became a Hurricane modification factory. The test sorties flew on September 23rd. When they landed 4 hours later, the results were undeniable. Hurricanes using Jimmy's modification averaged 348 miles per hour at 15,000 feet, 30 miles per hour faster than standard aircraft. 30 miles per hour, not 8 miles per hour like the wing spar modifications, not 12 miles per hour like the fuel additives, 30 miles per hour faster using materials that were already in every RAF storeroom. The numbers changed everything. Before Jimmy's modification, Hurricane squadrons were getting bounced and couldn't escape. They were losing interception races and couldn't catch up. After the modification, Hurricanes could nearly match Bf-109 speeds and level flight and could definitely outmaneuver them. Vincent didn't wait for permission from Fighter Command. He couldn't afford to wait. Every day of delay meant more pilots lost to aircraft they couldn't escape from. By October 1st, 48 modified Hurricanes were flying combat operations from Northolt, Tangmere, and Biggin Hill. Aircraft hands worked in shifts, taping wings as fast as their hands could move. The modification was simple enough that any ground crew with basic training could do it. No special equipment needed, no complicated procedures. Just apply tape, smooth it down, dope it, inspect, and send the aircraft back to service. 40 man-hours per Hurricane. Production scaled up faster than anyone expected. By November 1940, over 340 modified Hurricanes were deployed across Fighter Command. Every squadron that tried the modification reported the same results: 28 to 35 miles per hour speed increase, better handling, improved combat performance.
Luftwaffe intelligence noticed the change by late October. German pilots reported that Hurricanes were suddenly faster, matching speeds that previous intelligence said were impossible. Bf-109 pilots who'd been bouncing Hurricanes with impunity found their targets could now evade, could even counterattack. One captured Luftwaffe pilot told interrogators in November, "Your Hurricanes are different now, faster. We cannot bounce them the same way. They escape when they should be trapped." German intelligence tried to figure out what the British had done. They assumed new engines, supercharger modifications, weight reductions. They never figured out it was fabric tape smoothing rippled wings. Fighter Command officially recognized what Jimmy had accomplished in December 1940. They designated it Mackenzie's modification in technical orders. Every Hurricane produced after January 1941 received enhanced fabric surface treatment at the factory. Every frontline Hurricane was retrofitted with the tape modification during routine maintenance. It became so routine that pilots didn't realize their aircraft were special. The wings just worked better, flew faster, didn't drag as much. In February 1941, Jimmy received a field commission to pilot officer. A 23-year-old mechanic with a 6th grade education became an officer because he'd saved Fighter Command millions of pounds and possibly saved Britain by making Hurricanes competitive with Bf-109s during the critical months of the Battle of Britain. The enemies of innovation had been so sure they were right. The RAE engineers knew that wing structure was the problem, so they focused on spars and bracing. The fuel chemists knew that engine power was the answer, so they developed expensive additives. The officers knew that a mechanic couldn't possibly solve a problem
problem that experts had failed to crack. They were all wrong. They were wrong because they'd forgotten to question their assumptions. They'd forgotten that sometimes the biggest problems have simple solutions, and simple solutions often come from people who aren't trained to think in complicated ways. Jimmy didn't overthink it. He just remembered how his father smoothed motorcycle fairings in a Glasgow repair shop. And he asked himself why the RAF wasn't doing the same basic thing: keep the surface smooth, don't let turbulence start. It wasn't aeronautical science, it was common sense. The kind that comes from growing up poor and learning that waste is a sin. Nobody paid Jimmy royalties. He'd never filed for a patent. The idea belonged to the RAF, which meant it belonged to everyone. Jimmy Mackenzie went home when the war ended in 1945. He was 28 years old, a decorated officer who'd changed fighter aircraft maintenance forever, and he just wanted to go back to Glasgow. He'd seen enough, he'd done his part. Back home, Jimmy opened a small motorcycle repair shop, nothing fancy. He fixed bikes mostly, same as before the war. Never advertised, people just knew Mackenzie could fix anything. Jimmy never talked about the war. When customers asked, he'd say he'd been ground crew and changed the subject. He didn't mention the tape modification that saved Fighter Command, an aerodynamics breakthrough that cost 2 shillings and came from a mechanic with no formal training. He looked at a hurricane wing and asked a question nobody else thought to ask. What if we're just not keeping the surface smooth? That simple question increased fighter speed by 30 miles per hour, changed the Battle of Britain's dynamics, and reminded everyone that expertise without curiosity is just educated blindness. The next time someone tells you that's how we've always done it, remember Jimmy Mackenzie working alone in a hangar after midnight. Remember him watching fabric ripple and refusing to accept that slow fighters were inevitable. Remember him proving that common sense beats credentials every single time. Jimmy never accepted that things couldn't be better, couldn't be fixed with simple tools and clear thinking. He changed history with fabric, tape, dope, and the stubborn conviction that problems exist to be solved, not to be accepted. If this moved you, hit subscribe, because history forgets people like Jimmy Mackenzie, the mechanic who saved Britain with tape and common sense. Share this story. Keep these memories alive. Thank you for watching.